Welcome back to FuzeTox channel. In this video, we continue to explore and find out how the browsers work. It is the second part. It's a very huge part in compared to the previous part. So let's start. After HTML parsing, browser starts CSS parsing. And what is the CSS? CSS is cascading style sheets. Is a context-free grammar, and we have lexical grammar. Vocabulary is defined by regular expressions for each token. So for comment we have this regular expression, for noun this, for noun ASCII like this, and then start like this, and so on. So we have a syntax grammar is described as in bake now row form, being a form. We have a role set, selector, decorations, for class, selector, name, attribute, pseudo class, and so on. Also, we should say that Wiki has own CSS parser. Git uses Fex and Bison parser generators to create parsers automatically from the CSS grammar files. Bison creates a bottom-up shift-reduce parser. Firefox uses a top-down parser written manually. In both cases, each CSS file is parsed into a style sheet object. Each object contains CSS rules. The CSS rule objects contain selector and decoration objects and other objects corresponding to CSS grammar. So in this image we can see how it works. For this code we can each create CSS style sheet divided by CSS rules, and for each selector we have decorations. For these selectors P and U, we have decoration marking top with its property, and for selector class hero we have decoration color, which is red. So we also should say about order of processing scripts and style sheets. Nowadays we can use prefetch, preconnect, and fetch priority attributes, but this is not standard for nowadays web development. For scripts we can use synchronous and defer and model, async and defer, and attributes. So the model of the web is synchronous. If the script is external, then the resource must first be fetched from the network. This is also done synchronously, and parsing holds until the resource is fetched. We can add the defer and async, as I said before, attribute to a script, in which case it will not hold document parsing and will execute after the document is parsed. HTML fifths adds an option to mark the script as asynchronous, so it will be parsed and executed by a different thread. And no. So we can add async and defer, and they have difference, but I forgot. I always forgot which difference. So one of these do it in parallel thread, and defer do it when browser have idle time. So async defer difference, yes. Async attribute tells your browser that the script is not depends on the other elements and can be loaded at any time. And defer attribute tells the browser that the script depends on other elements and can be loaded in other thread. The order of processing script and style sheets. So we have speculative parsing. Both WebKit and Firefox do this optimization. While executing scripts, another thread parses the rest of the document and finds out what other resources need to be loaded from the network and loads them. The speculative parser only parses references to external resources like external scripts, style sheets, and images. the order of processing scripts and style sheets. Style sheets, due to the fact that some JS scripts are dependent on CSS styles, the browser is forced to block the use of CSS until the HTML is fully parsed. Firefox blocks all scripts when there is a style sheet that's being loaded and parsed. WebKit blocks scripts only when they try to access certain style properties that may be affected by unloaded style sheets. So we have a render tree construction. While the DOM tree is being constructed, the browser constructs another tree, the render tree. This tree is of visual elements in the order in which they will be displayed. It is a visual representation of the document. The purpose of this tree is to enable painting the contents in their correct order. Firefox calls the elements in the render tree frames. WebKit uses the term renderer or render object. A renderer knows how to lay out and paint itself and its children. Tree construction. WebKit renders object class. This class of the renderers has the following definition: class render object, virtual world layout, virtual world paint, paint info, virtual world rectangle, paint rect, node, asterisk node, render style, asterisk style, render layer, asterisk containing layer, the node, computer style, and the containing the index layer. Render tree construction. Each render represents a rectangular area, usually corresponding to a node's CSS box, as described by CSS2 specification. It includes geometric information like width, height, and position. The box type is affected by the display value of the style attribute that is relevant to the node. Render tree construction. Render object, asterisk render object, create object, asterisk node, render style, style document, switch case, break, inline block. Inline block, this item which will be another two fields for case grids and flags box. Render tree construction. The element type is also configured. For example, from controls tables have special frames. In WebKit, if an element wants to create a special render, it will override the create render method. The render is point to style object that contains non-geometric information. The render tree in relation to the DOM tree. The renders correspond to DOM elements, but the relation is not one-to-one. Another DOM elements will now be inserted into the render tree. An example is the head element. Also, elements whose display value was assigned to none will not appear in the tree, whereas elements with a hidden visibility will appear in the tree. The render tree in relation to the DOM tree. There are DOM elements which correspond to several visual objects. These are usually elements with complex structure that cannot be described by a single rectangle. For example, the select element has three renders, one for the display area, one for the top-down leaf box, and one for the button. Also, when the text is broken into multiple lines because the width is not sufficient for one line, the new lines will be added as extra renderers. The render tree, another example of multiple renderers, is broken HTML. According to the CSS specification, an inline element must contain either all block elements or only inline elements. In the case of mixed content, the anonymous block renderers will be created to wrap the inline elements. Some render objects correspond to the DOM node but not in the same place in the tree. Floats and absolutely positioned elements are placed in a different part of the tree and mapped to the real frame. Placeholder frame is where they should have been. So we have an image which describes how it's correspond one-to-one. So we have a viewport, scroll, bulk, and bulk of text. So the flow of the construction of the tree. In Firefox, the presentation is registered as listener for DOM updates. The presentation delegates frame creation to the frame constructor, and the constructor resolves a style and creates a frame. The WebKit process of resolving the style and creating a render is called attachment. Every DOM node has an attach method. Attachment is synchronous node insertion to the DOM tree calls the new node attach method. Processing the HTML body text results in the construction of the render tree root. The root render object corresponds to the CSS spec for the containing block, the top block that contains all other blocks. Its dimensions are the viewport. The browser window displays every dimensions. Firefox calls it a viewport frame. WebKit calls it render view. This is the render object that the document points to. The rest of the tree is constructed as a DOM node insertion. So we have the CSS specification. Style computation. Driven by CSS rules, browser faces with many possible problems. Style data is a very large construct, holding the number of style properties. This can cause many problems. Compound selectors. Applying the rules involves quite complex cascade rules that define the hierarchy of the rules. Sharing style data. WebKit nodes reference the style object, render style. These objects can be shared by nodes in some conditions. Symbols are sequence of occurrence, and the element must be in the same mouse state. Here the element should have an ID, the statement should match, the class attribute should match, and all the rows are described here. The link state must match, the focus states must match. Neither element should be affected by attribute selectors. The effect is defined as having any selector mesh that uses an attribute selector in any position within the selector at all. There must be no inline style attribute on the elements. There must be no sibling selectors in use at all. Macro implies rows a global switch when any sibling selector is encountered in the table styles sharing for the entire document, and they are present. This includes the plus selector and selectors like first child and last child. So Firefox rule tree. Firefox has two extra trees for each style computation, the rule tree and style context tree. It also has style objects, but they are not stored in a tree like the style context tree. Only the DOM node points to its relevant style. It describes how it works. We have a content and frames, and for each frame we have a style context. The style context contains end values. The values are computed by applying the matching rules in the correct order and performing manipulation that transforms them from logical to concrete values. All the matched rules are stored in a tree. The bottom nodes in the path have high priorities. The rules is done lazily. So we have a computer rule tree. Division into structs. Style contexts are divided into structs which contain style information for a certain category like border or color. Inherited properties are properties that are not defined by the element and inherited from its parent. Non-inherited properties use default values if not defined. The tree cache entire structs contains the computed end values in the tree. If the bottom node didn't supply any information for a struct, a cache struct in the upper node can be used. Computing the style context using the word tree. Starting at the bottom node with the highest precedence and moving up with the tree until the struct is fully specified. If a row node doesn't specify the struct, the optimization is to find the node higher up the tree that fully specifies it and point to it, thus sharing the entire struct. This optimization saves computation and memory. If we find partial definitions, we go up the tree until the struct is viewed. If we didn't find any definitions for our struct, then in the case the struct is an inherited type, we point to the struct of our parent in the context tree. If the more specific node adds values, some extra calculations are needed to transform them into actual values. The result is then cached in the tree node so that it can be used by the children. In case an element has a sibling that points to the same tree node, then the entire style context can be shared between them. It's all was in the Firefox, but in WebKit, if it doesn't have a rule tree, the matched decorations are traversed 4 times. First, non-important high priority properties are applied. Properties that should be applied first because others depend on them, such as display, then high priority important, then normal priority, non-important, then normal priority important rules. This means that properties that appear multiple times will be resolved according to the correct cascade order. The last wins. Rules management. So we have 4 sources for our CSS. It's external CSS, inline CSS with style tag, inline CSS with style attribute, and inline CSS with HTML visual attribute. This manipulation makes it much easier to match rules. There is no need to look in every declaration, and they can access the relevant rules for an element for the map. This optimization eliminates 95% of the rules, so that they need to not even be considered during the matching process. Both WebKit and Firefox do this manipulation. Applying the rules in the correct cascade order, if the property is not defined in any of the matched rules, then some properties can be inherited by the parent element style object. The problem begins when there is more than one definition. Here comes the cascade order to solve the issue. Style sheet cascade order. The order of applying the rules is very important. This is called the cascade order. So the cascade order is from low to high. Is normal user agent declarations, normal user declarations, normal FL declarations, animation declarations, important FL declarations, important user declarations, important user agent declarations, and transition declarations. Declarations with the same order will be sorted by specificity. So, specificity. A selector specificity is calculated for a given element as follows. Count the number of ID selectors in the selector, count the number of class selectors, attribute selectors, and receiver class in the selector, count the number of type selectors and receiver element in the selector, ignores the universal selector. When the selector is the selector list, this number is calculated for each selector in the list. For a given matching process against the list, the specificity in favor is that of the most specific selector in the list that matches. A few pseudo-classes provide evaluation context for other selectors, and so how the specificity defines specially. The specificity of an is not a has pseudo-class is replaced by the specificity of the most specific complex selector in its selector list argument. Analogously, the specificity on nth child child, one ch was child. Selector is the specificity of the pseudo class itself counting as one pseudo class selector, plus the specificity of the most specific complex selector in the selector list argument, if any. The specificity of where pseudo class is replaced by 0. After the rules are matched, they are sorted according to the cascade rules. WebKit uses bubble sort for small lists and a merge sort for big ones. WebKit implements sorting by overriding the bigger than operator for the rules. We have an example of code static bool operator. We present CSS raw data, R1 CSS raw data, R2, two integers. It's a R1 R2 selector. Specificity. It's a call function specificity, and we have two returns. Expression if specificity of first integer is equal to specificity of second integer, R1 position bigger than R2 position, otherwise specificity of one integer bigger than specificity of two, specificity of second integer. Regular process. WebKit uses a flag that marks if top level style sheets including at imports have been loaded if the style is not fully loaded when attaching placeholders are used and it's marked in the document and they will be recalculated once the style sheets are loaded. So layout, when the renderer is created and added to the tree, it does not have a positional size. Calculating these values is called the layout overflow. HTML uses a flow-based layout model, meaning that most of the time it is possible to compute the geometry in a single pass. Elements later in the flow typically do not affect the geometry of elements that are earlier in the flow, so layout can be proceeded left to right, top to bottom through the document. The exceptions, for example, HTML tables may require more than one pass. The coordinate system is wrote after the root frame. Top and left coordinates are used. Layout is a recursive process. It begins as a root renderer, which corresponds to HTML tag element of the HTML document. Layout continues recursively through the sum of all of the frame hierarchy, using geometric information for each renderer that requires it. The position of the root renderer is 0 and 0, and its top 0, left 0, and its dimensions are the visible part of the browser window. All renderers have a layout or flow method. Each renderer invokes the layout method of its tutor that needs layout. Dirty bit system. In order not to do a full layout for every small change, browsers use a dirty bit system. The renderer that is changed or added marks itself and its children as dirty within layout. There are two flags, dirty and children are dirty, which means that although the renderer itself may be okay, it has at least one child that needs a layout. Global and incremental layout. Layout can be triggered on the entire render tree. This is global layout. This can happen as a result of, first, a global style change that affects all renderers like a font size change as a result of the screen being resized. Incremental layout. Layout can be incremental only if the renderers will be laid out. This can cause some damage which will require extra layouts. Incremental layout is treated asynchronously when renderers are dirty. For example, when new renderers are appended to the renderer tree after extra content came from the network and was added to the DOM tree. Here state, added to tree, another state, render, another state, this state, removed, another state, and vice versa. Asynchronous and synchronous layout. Incremental layout is done asynchronously. Firefox queries flow command from incremental layouts and as casual triggers batch execution of this command. It also has a timer that executes an incremental layout with tree. The tree is traversed in insert renders layout out. Asynchronous and synchronous layout. Scripts asking for style information like offset height can trigger incremental layout synchronously. Global layout will usually be triggered synchronously. Sometimes the layout is triggered as a callback after an initial layout because some attributes like the scrolling position changed. Position and not size. The render size are taken from the cache and not recalculated. In some cases, only the subtree is modified and the layout does not start from the root. This can happen in cases where the change is local and does not affect the surroundings, like text inserted into text fields. Otherwise, every keystroke will trigger a layout starting from the root. The layout process. Parent renderer determines its own width. Parent calls all children and plays the child renderer sets its x and y. The layout process. Parent renderer determines its own width. Parent calls all children and plays the child renderer sets its x and y. Calls child layout if needed. There are dirty, Horia, and global layout, or for some other reason, which calculate the child's height. Parent uses children's accumulative heights and heights of mergers and padding to set its own height. This will be used by the parent renderer's parent sets its dirty bit to false. Firefox uses state object and its HTML default state as a parameter to layout. don't revolve. And one asset state includes the parents reads. The output of the Firefox layout is a matrix object, and this HTML4 matrix will contain the rendered computed height. These calculations. The rendered width is calculated using the container box width, the render style, its properties, emergence, and borders. The values are cached in case a layout is needed, but the width does not change. When the renderer in the middle of the layout decides that it needs to break, the renderer stops and propagates to the layout sphere that it needs to be broken. The parent creates the extra renderers and calls the layout on them. Painting stage, the renderer tree is reversed and the renderer's paint method is called to display content on the screen. Painting uses the UI infrastructure component. Like a layout, painting can also be global. The entire tree is painted on incremental. In incremental painting sounds, the renderers change in a way that does not affect the entire tree. The change to the renderer in validates is rectangle on the screen. This causes the operating system to see it as a data region and generate a paint event. The operating system does it collaboratively and coalesces several regions into one. In Chrome, it's more complicated because the renderer is in a different process than the main process. Chrome simulates the operating system behavior to some extent. The presentation listens to these events and allocates the message to the renderer tool to the renderer root. The tree is traversed until the relevant renderer is reached. It will repaint itself, and usually it's changing. The order is described by CSS2 specification. This is actually the order in which the elements are stacked in the stacking context. So this is a link to specification. Firefox display list. Firefox goes over the render tree and builds a display list for the painted rectangle. That way the tree needs to be traversed only once for a paint until of several times. Firefox optimizes the process by not adding elements that will be hidden, like elements completely beneath other opaque elements. Before painting, the kit saves the old rectangle as a bitmap. It then paints only the delta between the new and old rectangles. Dynamic changes. Browsers try to do the minimal possible actions in response to a change, so changes to an element's color will cause only the reprint of the element. Changes to the element position will cause the layout and reprint of the element, its children, and possibly siblings. Adding a long note will cause the layout and reprint of the node. Major changes like increasing font size of the HTML element will cause validation of caches, layout, and reprint of the entire tree. The rendering engine's threads. The rendering engine is a single-threaded. Almost everything except network operations happens in a single thread. In Firefox and Safari, this is the main thread of the browser. Chrome, it is the top process main thread. Network operations can be performed by several parallel threads. The number of parallel connections is limited, usually 2 or 6 connections. Event loop. The browser's main thread is an event loop. It is an infinite loop that keeps the process alive. It waits for events like layout and paint events and processes them. So we have a processing and the box model. It's a link to specification. Thanks for watching. Thanks for your attention. It is this article by this original article. Thanks for watching. Bye.